Okay, this is going to be the last part of the, this will be the applications part of the log and exponentials. Okay, so here there's an exponential regression. The thing you got to caution yourself with the years, okay, is that you should write it out. If 1991 or 1990 is going to be after X, we're going to make this 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And then what they want for 2018, we're going to treat 2008 like it is 18. Okay? So that's probably going to help you as you go through and do this. Okay? As a reminder, just like in class, I don't have the exponential part. Okay, so I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's just going to be 1 for a result, 1.142, 1.429, 4.286, 5.714, 10, 21.429, and 34.286, 59.143, and 70.314. Okay, so if I graph that, you can see it's an exponential. Calc, scroll, EXP. Okay, now I didn't get the selection here. Okay, I think when your calculator does it, okay, you'll end up getting a result of y equals 0.44 times 1.69 to the x power. Okay, so don't look at my equation, but from here on out you can. Okay, so I want to copy, execute. All right, and I go into the graph. Let me delete this other thing. What you got to do is make sure you hit select F1. I draw. All right, I saw it. If I ever need to do zoom auto though, sometimes that will help as well. Then zoom out, execute. I want to zoom out a bunch of times. Okay, so the question they ask is, all right, use your model, predict in 2018. Okay, so 2018, all right, so we said we're going to use 18, so we're going to do a y-cal there. Okay, G-solve, scroll, y-cal, and I put 18 in there, and it gave me a result of 5985, 5985.66. 85.66. Okay. Same thing with this one. Okay. Same thing with this one. Okay. They want to start this after, so we're going to treat this as 50, 60, 70, 80, 90, 95, 100. And 105, and 2020 is the one that they want. 2020, we're going to treat that as 120. Okay, the life expectancy, they want a log, okay, equation. So I'll go to stat and go to log, which move over here. So 50, 60, 70, okay, 80, 90, 95, 100, 105, and delete the rest of it. Okay, so 68.2, 69.7, 70.8, 73.7, 75.4, 75.8, 77, 77.8. Okay? If you want to look at the graph, that's like the logarithmic. Okay, calc, log, okay? So I got 15.09 plus 13.38x, natural log of x, sorry. Okay, copy, execute. Okay, now I'm going to go back. I just want to make sure I put the stats thing in correctly. Okay, looks right, looks right. Okay, all right, just want to make sure. Okay, so I go into graph, okay, to select, draw, then zoom out, execute, zoom out, execute, zoom out, execute. So they want to know what's the y-cal if I put in 120, and the answer is 79.15. Okay? All right, and the last question here. Determine that a regression equation relates to the cumulative number of domains that were purchased in the internet, then predict the number of purchases in the 18th month. Okay, so what we should do first, all right, they're not telling me what it is. Okay, so I'm going to go to stat. I'm going to put this in. Okay, let's delete all this stuff here, delete all this stuff here. Okay, I'm going to go all the way up to 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 211, 346, 422, 468, 491, 506, 522, 531, 540, 538, 551, 542, 565, 571, 588, and 593. If I look at that, that looks like a log to me. So I do calc, scroll, that's going to be a log. Okay, so I got 263.52 plus 122.86 natural log of x. Okay, copy, execute, go back into the graph, hit select and draw. Okay, so they want to know how many is purchased in the 18th month. So we are once again doing a y-cal, 618.66. Okay, all right, you could easily solve that if you wanted to do equations and substitute 0 in for those things and figure it out that way. You can do that as well, or substitute that number in and solve. Either way is possible, but use this in your notes to prepare for the summatives.